He's good, don't worry.
This is a wire, right?
Good evening, everyone. The
okay.
This Super Sunday, the final week of the 2010 Games is now underway. And for the Canadian host of these Olympics, something just maybe...
This is a wire?
Yeah.
Going through a hollow cylinder, right?
Okay.
The wire has surface density lambda charge, plus lambda, plus 1 lambda.
Okay, that's an E?
What?
In what? Charge in Q?
It's a surface charge, so it's
Like every spot of the charge has...
Yeah, it's uniformly distributed, it's charge per unit area, or charge per unit length.
Okay.
So, the charge on this wire going through this hollow cylinder is plus lambda. The net charge on the whole cylinder is 2 lambda. Plus 2 lambda, right?
The net charge is...
On the cylinder is 2 lambda.
Like from other source?
Net charge over the whole thing.
But is there other... Like the charge on the cylinder does not come from the wire, right?
Well, there is an induced charge, but it has a net charge of 2 lambda. It just holds the charge. It just holds the charge. So
when you say induced charge, if this is the charge entering...
I haven't gotten to the induced charge yet. This wire has a charge of plus lambda.
So when you take out the wire, how much do you have on this?
2 lambda.
Okay, that's all I know.
But you know that the net on this is 2. You want to know what the charge is on this inner surface and what the charge is on this outer surface.
Like when the wire is inside, the net
the whole system.
Will the net still be 2 lambda?
The net will still be 2.
How come? If the wire is outside, you have 2 lambda.
And the wire's on the inside, so if you remove the wire, this still has surface charge 2 lambda. But when you put the wire there, the charge on the inner surface and the outer surface will be different.
Oh, okay, I get it.
So this is how you use the Gaussian surface. This is your cylinder. If you draw a Gaussian sphere on the inside of the conductor like this, right? You know that there's 0 flux inside that conductor because on the inside of a conducting thing and it's in an electric field, there's always 0 flux.
Right.
So because you know that there's 0 flux in this Gaussian surface, that means that there must be no net charge enclosed by it. So if the wire has plus y lambda, then the inside of the sphere must have negative lambda, right? And then if the net charge on the whole thing is 2 lambda, then the charge on the outer surface has to be 3 lambda. It's going to be the 3 minus the 1 from in there.
Okay, that's a little bit better.
I mean, the idea of the Gaussian surface is it's a tool to tell you when there is and isn't flux to see if there's a net magnetic field there.
Okay, that helps a little bit.
Yeah.
But still, like, this is a way to use it, but just explain to me what it is.
It's an imaginary object.
And where? Like, forget about it. So I have a field here.
Yeah.
Right. Whatever.
Yeah.
So the object is the imaginary object would be, say this.
Yeah.
And what does it help me?
In terms of flux?
Yeah, I know E of this field.
Yeah.
I know it like from E.
Yeah.
What does that imaginary object help me when it's just like this?
Well, it's just like this. There's definitely a field there, and there is flux here because it's a one-plane surface.
When you say flux, what do you mean by flux?
There is a net field flowing through this. If
so flux is the field acting on an object? Is that
it is a measure of how much field there is in a given surface area.
Okay.
So, but I mean, if your field is going like this, and then you drew your Gaussian surface like this, if it's Q, net flux is 0 because there's the same amount entering as there is leaving.
In the conductor.
Well, this is just a Gaussian surface. This doesn't exist.
Oh, okay.
But it's saying through this surface there's 0 flux because the same amount of field lines coming in are the same amount leaving.
Okay, that helps a lot more.
So the only way you'll have net flux is if you're enclosing a charge like this.
Today on NBC's Meet the Press, General David Petraeus, the overall commander of the Afghan war, said his forces were facing a
I kind of get it, but do you have a clear picture of what is a Gaussian?
I kind of understand it's a tool that you would use in situations like this.
Yeah, but that I understand, but
yeah.